Okay, coming back with another type of sequence or special type of sequence. It's called the arithmetic sequence or arithmetic sequence. Before we talked about geometric sequences having a number that you constantly multiplied by to get the next term. Well, with arithmetic sequences, you have a number that you're constantly adding to get the next term, and that number is called the common difference. I'll show you here two different formulas as to how to write a rule for arithmetic. Here's my first one. This one involves the first term, and you need the common difference. This second rule, you still need the common difference, but I go and I get what's called the zero term. So this would be the term just before the first one. Or that would be A1. Okay, and I'll show you why I kind of like that one a little bit better. But here, let's get started with a couple examples. Is this sequence arithmetic? Yes or no? And I'm also going to say if it is yes, then we're going to write a rule for that. So this one, I go from 5 to 6. Well, or 5 to 11. There you go. I gave it away. I added 6. And I'm going to add 6. And I'm going to add 6. Well, that's my common difference of 6. I need my first term. And I'm going to write a rule with the first method. So I'll take the first one plus n minus 1 times d. So 5 plus n minus 1 times my 6. Now, with equations, I typically tell my students make sure that there's an x and a y in your answer. In this case, there's always going to be an a sub n with that little n and an n in your formula or your rule. So I'm going to just manipulate this a little bit, distribute 5 plus 6n minus 6. 6n minus 1 ends up being my rule. Okay, so basically what that does for me is, let's say I want to find the, well, this would be the 1, 2, 3, 4, 5, 6 spot. If I were to put in the 6, 6 times 6, 36 minus 1, that number would be 35. Now, the other way I could go about looking at this is I'm going to go backwards one spot. So I'm going to look for this number right here, and that would be my A0. So what number could I add 6 to get that 5? Well, -1. Or I could take 5 minus 6 to go backwards and get -1. So my rule this route would be my common difference times n plus my 0 term. Well, my common difference is still 6, so 6n minus 1, which is the exact same rule I get there. The reason why I like this one a lot better is a lot quicker. I don't have to go through distributing that 6 and doing the parentheses and things like that. And this is really the same thing as y equals mx plus b, where that would be my y-intercept, and my y-intercept is always 0 comma something. So my 0 term, 0 position. And then 6 is just my slope. Okay, only difference here, I am going down, so it's still adding, but I'm adding a negative number, so -2. And I'll go to find my 0 number right there, and that a sub 0 is 11. So my rule for this guy would be a sub n is equal to -2n plus 11. See how nifty that can get. So here, looks like would add 4, but then I add 2. So this is maybe some sort of rule, but it's definitely not arithmetic. Okay. So here, I want to find, and what this means with this a is little 12. So the way to read that would be find the 12th, or I should say find the number in the 12th spot. So if I put n is equal to 12 in, I would know what the 12th number is right there. Now, I could keep on using the common difference until I get to the 12th spot, or I could do it this way. It looks like I am adding, what would be, 15 plus 15. So to go backwards, this a sub 0, or the 0 position number, let's see here, that would be, take away 10, 22, 27, no, 17. So the rule would be a sub n is equal to 15n plus 17. And if I want to figure out the 12th term, so with this little 12, that is the 12 that would go in for n. So I'm looking for the number in the 12th spot. So 15 times 12 plus your 17, it ends up being 197. Okay. There you go. And if you wanted any position, actually, if you say wanted to find, say, a equals, or a to the little 100, that means I want to find the 100th number. That would mean that I'd go 15 times 100 plus 17. Now, putting in that 100 is a lot quicker than adding 15 times, I don't know, 15, maybe 97 times, 94 times. So the last thing to do is, how do I come up with a rule with various different information? Well, I always get tripped up with this, or when I was younger, about looking at something like this. There's actually two pieces of information in here. That little guy tells me I'm looking at the 20th number, and the actual answer to my rule is negative 111. Okay, so if I'm 20 in and I have a common difference of negative 6, it's really how many negative 6s did I count? Well, 20 of them to get to that 0 position. So now it's just kind of plugging values in and solving for the unknown. So add that and I get, 9? Make that a little bit more pronounced. So then the overall rule for any specific term would be negative 6n plus 9. And if you want to check that out, put in a 20. 20 times negative 6 is negative 120, plus 9 is negative 111. Okay, another possible situation. In here, like I did with geometric, since I've got two terms and two spots, I'm going to write a system of equations. So, equation number 1, 10 equals d times 5 plus 10. I'm sorry, not 10 a naught. Remember, I've got the 5th spot worked out to be 10. So over here, I've got 110 equals d times 30 plus a naught. And really, this is the solving equations of two lines. I could do it multiple ways, but I'm going to do substitution. So I'm going to pick the top one, and I am going to make it so that I have a sub 0 by itself. So I'm going to subtract 5d from both sides. And then I'm going to take this, and I am going to plug it in right there. And I've got something like 110 equals 30d plus 10 minus 5d. Combine those two like terms, so 25d plus 10 equals 110, subtract 10, 100 equals 25d. d is equal to 4. My common difference is 4. Okay, now I'm going to take that common difference, I'm going to put it into this guy right here to come up with my first, or my 0 term. So 10 minus 20, negative 10. So my rule is a sub n is equal to 4n minus 10. And that is how you write the equation of an arithmetic sequence. Remember, arithmetic is just lines. And if you look back at the geometric, that's just geometric growth or decay. Stuff we've done just with little different notations. The a sub n replaces y in our equations, and n replaces x. So hopefully that helps out.